Okay, if you are in Math 7, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 4.3, example 2, and it can be found on page 160. Okay, this is what we did yesterday. We're just kind of building on it. There's nothing new here. Okay. The weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. Okay, so the first thing I notice about this word problem is the word proportional. Now, I know that a proportional linear equation is equal or the same thing as a direct variation equation. And I know that the equation for this is y equals mx. If it's proportional, the plus 0 is invisible. Okay? So a proportional linear equation is also known as a direct variation equation, same thing. And I know the equation for that is y equals mx, and the plus 0 is invisible. Okay, I also know that m is my slope, and it's also called the constant of proportionality. So m is my slope, but it's also known as the constant of proportionality. It's what makes it a proportional linear equation. Okay? So the word problem told me we have a proportional relationship. And I know that this represents a proportional relationship. Okay, so we have y equals mx. Now it's telling me y is the weight of an object on Titan. So y is the weight of an object on Titan. X is the weight of an object on Earth. So x is the weight of the object on Earth. And we still have our constant of proportionality, or our slope. So Titan, the weight of something on Titan is equal to our constant of proportionality times Earth. Okay, so I'm labeling everything. I'm using the information that the problem gives me, and I'm labeling everything. Now it tells me an object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. 105 pounds on Earth is 15 pounds on Titan. And it asks me to write an equation that represents the situation. Okay, so I need to write an equation that represents the situation. I need to find my slope or my constant of proportionality. Can I do that? Absolutely. I need to isolate m, but m is being multiplied by 105. So I need to undo or get rid of that 105. So I'm going to divide by 105. What I do to one side, I must do to the other. I know 15 divided by 105 is 1/7 equals, these guys cancel, there's my M. So here's my constant of proportionality. Now they're asking me to write an equation that represents this situation. Write an equation that represents this situation. Y equals 1/7 x. This is the equation that represents the situation. Okay, so this was the first part of the question. Write an equation that represents the situation. We've done that. Now, the second part of the problem is telling me how much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Okay, here's my equation that represents the situation. Y is Titan. X is Earth. Everything else comes down. The problem is telling me we have a chunk of ice that weighs 3.5 pounds on Titan. How much would it weigh on Earth? We're just substituting. We're plugging in the information that they give us. So we need to know how much it would weigh on Earth. I need to get rid of this times 1/7. So I'm going to multiply by inverse operation, by the inverse, by the reciprocal. Sorry, I'm going to multiply by the reciprocal, 7/1. What I do to one side, I must do to the other. So 7 times 3.5 is 24.5 equals, these guys cancel, X. And we said X was Earth. So this means the chunk of ice would weigh 24.5 pounds on Earth. That's what it means. So we had to find our slope or our constant of proportionality to create an equation that represents the situation. Then they told us there's a chunk of ice that's 3.5 pounds on Titan. How much would it weigh on Earth? So now it's substitution. Not too bad. Okay, let's do a second example. Okay, in this problem, the daily wage, Y, in dollars, of a factory worker is proportional to the number of parts X assembled in a day. Oh, so here's that clue word, proportional. If it's proportional, I know that it's Y equals MX. If it's proportional, I know it's Y equals MX. Now, in this problem, they're telling me Y is dollars and X is parts. Okay. So it continues. A worker who assembles 250 parts in a day earns $75. So now we need to substitute parts. 250 parts earns $75. We need to write an equation that represents the situation. That means we need to find the constant of proportionality here. Can we do that? Yes. Okay, we can find our constant of proportionality. However, it's attached to this times 250. So I need to use inverse operations. I need to undo 250. I'm going to divide by 250. What I do to one side, I must do to the other. So 75 divided by 250 is 3/10. These guys cancel. M. Here is my slope or my constant of proportionality. There it is. But it's asking me to write an equation that represents the situation. Okay, we know that it's proportional. My constant of proportionality goes there. This is the equation that represents the situation. Here's the equation that represents the situation. So this gives me the chance to play with it a little bit. I can say, what if somebody makes 400 parts in a day? How much money will they make? Or somebody made $110. How many parts did they make? This equation gives me the opportunity to play around with it. Okay, the second part of the problem is asking me, how much does a worker earn who assembles 300 parts in a day? So we know Y is money. We know X is parts. They're asking us, they're telling us somebody made 300 parts. So how much money did they make? So we're just substituting this in. Can we figure out how much money they made? Absolutely. Y equals 3 times 300 is 900. Divided by 10, Y equals 90. But what does this Y represent? The Y represents dollars. So this means that a person a worker will make $90 for the day. If he made 300 parts, he will make $90 for the day. So the trick to doing all of this is making sure to label your X's and your Y's. Label everything so that you know where to substitute your numbers into. Okay?